As far back as 1895, we understood that carbon dioxide would act like a greenhouse gas, leading eventually to climate change. Nobel laureate Svante Arrhenius, that to me looks like Harry Potter's abusive uncle, Vernon Dursley, but maybe that's just me. So he described this, and everybody thought, wow, golly, that's amazing, and we should give you a Nobel Prize. But of course, we didn't listen to him. Um, Starting in 1957, Charles Neeling, who we've already talked about, started directly measuring carbon dioxide concentrations in the atmosphere, giving us this Neeling curve that we've already looked at. The carbon dioxide concentration is shown in this wiggly red line, and the global average temperature is overlaying on that. Uh, and we can see that as our carbon dioxide concentration increases, so too does the global temperature. So those guys are tracking each other. Those are very correlated. Now, if you are practicing responsible skepticism, you might say to yourself and to me, Julia, correlation does not mean causation. And to you, I would say, thank you for being a responsible skeptic. But let's talk about how we can actually show that the global average temperature is directly linked to carbon dioxide concentration. Okay, we can do this through computer modeling. Okay, so computer modeling is just a really big fancy math equation, and we can control the variables that we put into this equation. So computer modeling allows us to untangle confounding variables and act like a control group when we don't really have one. The International Panel on Climate Change, which is an international body of scientists, policymakers, economists, and a bunch of other really smart people, they release a report every 5 to 7 years on the state of climate globally. And in the 2021 report, they included climate models that disentangle the natural causes of climate change, like volcanoes, wildfires, stuff like that, with the human cause sources of climate change. And so if we look at this graph, this blue line is going to give us our simulated natural factors only, right? So if we're looking at things like volcanoes and natural wildfires, we would expect to see that our global average temperature would remain the same as what it was previous to the Industrial Revolution, which is our zero line in this case. But what we can do, so that's our control group. And now let's have our experimental group where we're including natural factors and human-caused factors of global change. And that's what we see in this purple line here. And we start to see this divergence from our natural causes of climate change to our human causes of climate change in the 1950s. Okay, and this this shaded region is our error, right? So we've talked a lot about the variability around the mean being really important. So this is just like our error bars in this kind of line graph. And so this shaded region and this shaded region do not overlap. So we can say for sure that humans are causing climate change. Another kind of just piece of evidence that supports that is that what we actually observe, shown here in the red line, tracks almost exactly the simulated factors of both humans and natural causes.